Hello everyone, I am Vishnu CH, currently studying in Sri Venkateshwara College of Engineering, branch CSE CY. Today our topic is binomial distribution in mathematics. So first let us come to the introduction to binomial distribution. The binomial distribution is a probability distribution that models the number of successes in a fixed number of independent Bernoulli's trails. It is characterized by two parameters, the number of trails denoted as n and the probability of success in each trail denoted as p. The binomial distribution is widely used in various fields, including statistics, genetics, and finance. There is a reference graph given aside. You can refer that. Now, let us come to the next topic, that is formula for binomial distribution. The probability mass function, that is PMF, of the binomial distribution is given by the formula P of x is equal to k, that is equal to n choose k, that is p to the power of k. So the formula 1 minus p to the power of n minus k, where x is the random variable representing the number of successes, k is the desired number of successes, and n is the total number of trials. P is the probability of success in each trial, and n choose k represents the binomial coefficients. There is a formula given aside, you can refer that. Now the next topic, that is mean and variance of binomial distribution. The mean of a binomial distribution is given by the formula mu is equal to np, where mu represents the expected number of successes. The variance of a binomial distribution is given by the formula sigma to the power sigma square is equal to np into 1 minus p, where sigma square represents the measure of dispersion. The standard deviation of a binomial distribution is the square root of the variance, that is sigma is equal to root of np into 1 minus np. Binomial probability distribution. The binomial distribution with n trials and success probability p as mean, that is np, variance, that is sigma square is equal to np into 1 minus p, and standard deviation, which formula is root of variance, that is root of np into 1 minus p. Now, example of binomial distribution. Consider a scenario where a fair coin is flipped 10 times and we want to determine the probability of getting exactly 3 heads. In this case, n is 10, that is the number of trails, and p is 0.5, that is probability of heads in each trail. As you know, heads and trails are both off in one coin, so the probability would be 0.1. We take it in decimals. Using the binomial distribution formula, we can calculate the probability as p of x is equal to 3 is equal to 10 choose 1. The answer is given beside, you can refer that. Now the next topic, that is cumulative distribution function, which represents CDF. The cumulative distribution function, the binomial distribution, calculates the probability of obtaining up to a certain number of successes. It is obtained by summing the probability of all possible outcomes up to and including the desired number of successes. The CDF can be useful for determining the probability of achieving a specific range of successes. Application of binomial distribution. Binomial distribution is commonly used in quality control to determine the probability of a certain number of defective items in a sample. It is widely used in genetics to model the inheritance of different alleles and traits. It is utilized in marketing research to analyze the response rates in surveys or experiments. Relationship to normal distribution. When the number of trails is large, that is n greater than 30, and both np and n into 1 minus p are greater than 5, the binomial distribution can be approximately by the normal distribution. This approximation allows for easier calculations and is often used in practice. The mean and standard deviation of the normal approximation are given by mu is equal to np and rho is equal to root of np into 1 minus p. Normal distribution gap representation. The limitations of binomial distribution. The binomial distribution assumes that each trail is independent and has the same probability of success. It may not be appropriate for situations where the probability of the success changes over time or is influenced by previous outcomes. The binomial distribution is not suitable for continuous outcomes. Now, let us come to the importance of binomial distribution. The binomial distribution is fundamental in probability theory and serves as the building block for many other distributions. It provides a useful framework for modeling and analyzing real world phenomena involving discrete outcomes. Understanding and applying the binomial distribution is crucial in statistical inference and decision making. Binomial formula. If you have only two possible outcomes, call them 1 or O, or yes or no, or successive or failure in n independent trails, then the probability of exactly x is success, that is n of number of trails. The formula is given, you can refer that. Now, conclusion. Binomial distribution is a powerful tool in mathematics for modeling the number of successes in a fixed number of independent trails. It is characterized by its formula, mean, variance, and relationship to the normal distribution. Its applications span various fields, and understanding its limitations is essential for accurate analysis and interpretations. Binomial distribution formula. Here is the formula where n, which represents the